Hello, welcome to the SciCon Machine Learning Tool tutorial. Today we're going to be talking about decision tree regression. So, a little bit of introduction to regression. The goal of regression is to define a relationship between one dependent variable and one or more independent variables. It attempts to draw a best fit line through the data points that best represents their pattern and clustering. So the graph to the right, for example, shows a linear regression where you're trying to draw a straight line to best fit the spread of data points. Decision tree regression specifically has the goal of making a prediction based on data features and the loss function in a form similar to how a flowchart may work. The data is split based on features, and the performance is evaluated through the loss function, which is the difference between predicted and actual values. The model attempts to split the data in a way that minimizes the loss function and best fits the data. So we are going to be using some example phytomining data. So just as an introduction, phytomining is the cultivation of special plant species with the goal of harvesting them to obtain metals from soil. The input features for this kind of data may include species and variety, treatment, soil metal concentration, and others. So this is an example flowchart showing how a decision tree might work. It asks a series of questions about the data, and depending on whether yes or no is answered, it gives predictions showing how many micrograms per gram of, in this case, rare earth elements are accumulated within the plant biomass. To evaluate the model, right now we're going to look at the coefficient of determination, or R-squared value, although there are other ways to evaluate the models. The R-squared value represents the proportion of the variation in the dependent variable that is predictable from the independent variable or variables. It indicates the goodness of fit of a regression model. This equation shows how the R-squared value is calculated using y hat, which is the predicted value, yi, which is the actual value, and y bar, which is the mean value. An R-squared value closer to 1 means that there is a small difference between the predicted and actual values, and the model is a good fit for the data. Before we actually use the model, we need to transform the data set in a way that the program can understand. So this is an example phytomining data set. As you'll see, the species, variety, and tissue columns are a mixture of spaces and letters and numbers and other symbols. The program does not understand these different names, and so you actually must pre-process the data and encode it to let the program know that these are different categories that you want it to recognize. So now you'll see that species, variety, and tissue have been turned into categories represented by numbers. And these, along with the other independent variables, will help inform the dependent variable, the total rare earth element concentration. So now we're looking at the SciCon program. The first thing you're going to want to do is name your project and then add a little bit of a description. For my description, I talk about how we're going to be using the SciCon ML program to perform decision tree regression using experimental phytomining data from research at the University of Idaho. And I talk about how the steps we're going to cover are uploading data, selecting the target label, selecting the machine learning model, and running the model to evaluate its performance. So I've already uploaded the data by clicking Upload CSV and then clicking on this icon and selecting my data. For the data type, I'm going to select tabular because it's a CSV file. And you can look at my data here within this window. And you can also use this data tab here to get info about your data. It tells you the amount of rows and columns. It tells you the number of null instances in your data, the data types, and all the unique values for each group. So once that's done, I'm going to go to my pre-processing section here. For my target label, I'm going to select what I want to predict, or my dependent variable, which in this case is the total rare earth element concentration. I'm going to select machine learning algorithm for my method. And then for my class, I'm going to select decision tree regression. Once I have my decision tree regressor picked out, I'm going to pick a category for evaluation, and in this case, I'm going to choose that R² value. Then I'm going to click perform. So I get this graph here. Because we have multiple independent variables, this graph isn't really going to tell us anything. But what we want is the R² value here, which is that 0.98. And if you'll remember from before, an R² score that is close to 1 means that the model works very well with the data and is a good fit. Another thing to take a look at are these y-test and y-prediction values. The y-prediction values are values that the model has predicted based on training data, and these y-test values are real values from the data that are used to compare the performance of the model. So this has been the Scicon machine learning tutorial for decision tree regression. Thank you for watching.